Hi everyone, Morgan here once again, doing AP Chemistry from home. We are on page 3 of the kinetics outline, and we are going to look at something that we call the method of initial rates. When we try to measure a reaction rate, we want to do it initially when the reaction begins because that's when the rate is going to be its highest. Now what we have here are 4 different trials of the same reaction with different concentrations of the reactants so that we can compare the rate laws. Now I know that the rate law R will equal K times the concentration of I minus raised to the X times the concentration of OCl minus raised to the Y. And if I read the question, I also see hydroxide is involved as a catalyst raised to the Z. Okay? Now, what I don't know is the value of K or X, Y, and Z. So I need to determine that by comparing the rates in different experiments. Now, algebraically, I'd really like a situation where only one thing changes at a time. So the hypochlorite ion changes from 1 to 2, the others stay the same. So I'm going to compare reaction 2 and reaction 1. Or trial 2, trial 1, whatever you want to call it. 2.42, I'm sorry, I started out that wrong. I apologize about that. 4.82 times 10 to the negative 4th molar per second equals K times 2.00 times 10 to the negative 3rd raised to the X, 4.00 times 10 to the negative 3rd raised to the Y, and simply 1.00 raised to the Z. That's for trial 2 or experiment 2. Now I have 2.42 times 10 to the negative 4th molar per second equals K times 2.00 times 10 to the negative 3rd raised to the X, 2.00 times 10 to the negative 3rd raised to the Y, and 1.00 raised to the Z. So what I did was I wrote out the rate law for what I thought it would look like without the exponents being known, so they're variables. And then I'm just taking the data from one trial and dividing it by the data from another trial. Now, I don't know what K equals. But what I do know is that K is a constant, so it'll cancel. I don't know the value of X either, but I do know that the X up here and the X down there are the exact same number. So the same number raised to the same number, I can cancel those. And I can do the same thing there for the same reason. Now what I have is this divided by this, which is equal to 2, which equals that divided by that is equal to 2, but raised to the Y power. Well, that tells me Y must equal 1 because 2 equals 2 to the first. Okay. Now, I know Y. I can try and find X and Z. This time, I'm noticing a change in the I minus concentration. So I'm going to compare numbers 3 and 1, not 2 and 3. Then I'd have two things changing, which would be a little more challenging algebraically. 5.02 times 10 to the negative 4th molar per second equals K times 4.00 times 10 to the negative 3rd, that's going to be raised to the X, times 2.00 times 10 to the negative 3rd, which is raised to the first. I already determined that. And 1.00 raised to the Z over 2.42 times 10 to the negative 4th molar per second equals K times 2.00 times 10 to the negative 3rd raised to the X times 2.00 times 10 to the negative 3rd raised to the first, 1.00 raised to the Z. Now, I can immediately cancel out those and the K's. And what that leaves me with, this divided by this, which is essentially equal to 2. Remember, this is experimental data. So it might be a little different out there and the third or fourth sig fig, but I don't need to go that far. This divided by this is again equal to 2, raised to the x, and x is also showing to be 1. Now that doesn't mean that these exponents are always 1, but they're very often 1 because the order is telling you the number of species that are involved in a collision. And it's not statistically likely that you're going to have 3, 4, 5 different species colliding with each other. It's going to be one of them. Okay. Now, 4 and 1 will be my last comparison. 4.64 times 10 to the negative 4th molar per second equals K. It's 2.00 times 10 to the negative 3rd. That's raised to the first. 2.00 times 10 to the negative 3rd. That's raised to the first. And 0.500 raised to the z. Over 2.42 times 10 to the negative 4th molar per second is K. 2.00 times 10 to the negative 3rd. 2.00 times 10 to the negative 3rd. And 1.00 raised to the z. So what I'm seeing now, after these all cancel out, is something a little bit different. 2 equals 0.5, or 1/2 raised to the z. And z must equal -1, which means what is happening is that since I said hydroxide is functioning as a catalyst, it's an inhibitor. It's making the reaction slow down rather than speed up. Now, most people at this point would write this in this format. To the first, to the negative 1. I do it slightly differently. Algebraically, it's the same thing. K equals I minus times OCl minus, and you can put the ones or not put the ones, it's up to you. But I'm going to divide by the hydroxide ion. And that tells me that increasing concentration of hydroxide is going to slow down the rate. Okay? Now, what I'd like you to do at this point is to flip to the next page here and try this question on your own, and then tune back into the next video to see how this goes. All right, this is Morgan signing off.